Continuing lesson 7.7, simulating compound events. If we look at workbook page 95, number 1, a boy wins a carnival game 50% of the time. He uses a spinner with equal sized sections labeled 0 through 9 to simulate trials of the game. In the simulation, the numbers 0 through 4 represent winning, and the numbers 5 through 9 represent losing. And understand that 0 through 4, 0, 1, 2, 3, 4, that's 5 options. Okay? Sometimes people look and think, well, that's only 4. 5 through 9, 5, 6, 7, 8, 9, that's 5 options also. So that's a 50-50 chance we got. So based on the simulations below, what is the probability he wins all 3 times? Okay, and again, this is based on his simulations. Alright, we're not actually being asked to figure out theoretically what the chances of him winning all 3 games. We could do that, but they're just saying based off of what he did here, what's the probability of him winning all 3 times. So remember, winning would be the numbers 0 through 4. So we're looking for combinations of numbers that all 3 numbers are from 0 through 4. So the options here where he wins all 3 times, 412, all those are from 0 through 4. 424, all of those are from 0 through 4, and 121, all those are from 0 through 4. All the other ones have numbers involved that are not between 0 and 4, so kind of highlighting why these other ones don't work. Okay, we look at number 2. Oh, sorry. So the probability, to finish off there, we had 3 out of a total of 10. So 3/10, or if you wanted to say 30% chance of winning all 3 times. Number 2, probability a certain bacteria colony thrives in a laboratory conditions is 70%. In a simulation, the numbers 0 through 6 represent bacteria colonies that thrive, and 7 through 9 represent bacteria colonies that do not thrive in the laboratory. There are 4 total bacteria colonies, results of 6 trials recorded below. Based on the simulated results, what is the probability? And again, based on the simulated results, we're not being asked to figure out theoretical here. What's the probability that exactly half of the colonies will thrive? Okay, so each time with our numbers here, you can see there's 4 different numbers, which is what they told us, 4 total bacteria colonies. So we want half of them to thrive and half of them not to thrive is what we're looking for. So for them to thrive, again, that's the numbers 0 through 6. So basically what it boils down to is that we want in our sets of numbers, 2 of them should be 0 through 6, 2 of them should be 7 through 9. So looking through these, ones that have exactly 2 out of the 4 that are from 0 through 6, 3829 would be one, and then 2868 would be the other one. This first one, there's a 425, that's got 3 of them. Second one, we got 603, that's got 3 of them. Third one's only got 1, or the fourth one I should say, and then the last one has got a 513, that's got 3 of them. So just those 2, so that would be 2 out of 6, which we could reduce to 1/3. Okay, so 1/3, if you wanted to, that's 33 1/3%, or 33.3 repeating percent chance of that happening. Number 3, a fair coin is used to simulate the gender of each child in a family with 3 children. In the simulation, a coin that lands heads up represents a girl, and a coin that lands tails up represents a boy. Simulation is conducted to generate the gender of each child from 10 families. Based on the simulated data, what is the probability that a family with 3 children has exactly 2 girls? I'm going to circle that with black here because I did that for girls earlier. Okay, so exactly 2 girls means we want exactly 2 of the letters to be what?
To be
H. Okay, so we're looking at all these different options. We want exactly 2 H's. So looking through our list here, we're looking for ones that have 2 H's. So one that has 2 H's would be family 1. Another one would be family 4, family 7, family 9, family 10. If you look at the other ones, the others do not have exactly 2 girls. So that would be 5 out of 10, or we could reduce to 1/2, or you could say 50%. Number 4, chance that it will rain in the town where a family is spending vacation is 60% for each of 3 days. A spinner is used to simulate the weather pattern over the 3-day period. There are 5 equal-sized sections, 3 sections labeled R to represent days with rain, and 2 sections labeled N to represent days with no rain. So there's the results. And then what is the experimental probability? It will rain exactly 1 out of the 3 days. So rain is the R. So exactly 1 out of the 3 days with rain. So raining exactly 1 out of the 3, we only want 1 R. So NNR, we got an NRN, we got another NRN. So that would be 3 out of 8. So we got a 3/8 chance of that happening. A little less than half. Number 5, of all listeners who call the local radio station on the telephone, 60% are between the ages of 15 and 25. A random number generator is used to simulate 20 groups representing the next 6 listeners who will call the radio station. Simulated data is recorded below. Which of the following describes the possible numbers that may be used to represent listeners within and outside of the age range? Okay, so what we're doing on this problem is they are asking us what kind of way would we simulate this. So 60% are between 15 and 25. So 60% are between that means 40% are not going to be between that. Okay, so within the age range, that's the 15 to 25 age range is what they're talking about. Okay, so when we look at this on A, we want 60% of the numbers to be between 15 and 25 or within the age range, and 40% to be outside the age range. So easiest way would probably be is if we come up with 10 numbers. 60% is how many out of 10? 6 out of 10. So if we can get 6 out of 10 within the age group, 4 out of 10 outside the age group, that's what we want. So if you look at this choice A, we've got 0 through 5. 0, 1, 2, 3, 4, 5. That actually is 6 numbers, so that's okay. Outside the age range, 6 through 10. 6, 7, 8, 9, 10. Oh, that's 5. So that would be, this is 6 and this is 5. That's 6 out of 11. that does not equate to 60%. So that one doesn't work. You look at B, 0 through 4, that's going to be 5 numbers. So probably not going to work. 5 through 9 is also 5 numbers. So that's 50-50. That's not what we want. C, we've got 0 through 6 is 7 numbers. 7 through 9 is 3 numbers. So that's 70% chance. That doesn't work. So hopefully it's the last one here, or we messed up. This is 6. And then 6 through 9 is 4. That's 60% versus 40%. So that would be it. So choice D for that part. And then part B, based on the simulated data, what is the probability the next 6 listeners that call are between 15 and 25? So if this is what we chose as our simulation, basically we're saying all of the numbers have to be between 0 and 5. So if we go back up and look at all these, they've got quite a list here. So basically what's going to end up happening after we look through them all, it's not going to be very common for that to happen. So these should be the only 2 out of that whole group that fall in that group of 0 through 5s for every single number. So that would be 2 out of 20. There's 20 altogether there, so that's 2 out of 20, which is 1/10 or 10% chance of that happening. And then C, how will the simulated results change if a different set of numbers are assigned? As long as we have the 60% versus 40%, we should be in good shape. You know, if I do 0 through 5, or if let's say, well, now let me change it. Let's say now it's 10 through 15 and then 16 through 19. It's still going to be the same chance of that happening if we assign different numbers. Was just pointed out a mistake I made here a second ago. This is 2 out of 20 actually reduces to 1/10, which is 10%. So I had a wrong denominator to start out with there. Number 6, probability the Mustangs win a certain game is 50%. A fair coin is used to simulate the team's chance of winning 4 of the next 7 games. A winning game is represented by heads up. So we want 4 of the next 7 to be wins. 4 of these need to be heads then. So if we go through these again, there's quite a few letters to look at here, but what should happen is we've actually got 4 of these groups. So 4 out of 6, which is 2/3 chance that they're going to win 4 of the next 7 games. And then part B, what's the probability the Mustangs will win 4 games before playing all 7 games? There were 2 different options here. These 2 I drew arrows to where they actually already won before we got to the 7th game. So that would be 2 out of 6, which is a 1/3 chance that they would win 4 games before they played all 7. So this gives you an idea of how to simulate compound events.